Hello, Grid Investor Network. I am Danielle Palloschi-Browne. I am an agent and investor here with in Grid and the DMV area, and this is my co-host Raj, engineer and custom home builder here in the DMV. And today we are going to be talking about, we are starting our new sub-series of our blueprint series, our structural drawings. So we're going to be diving deep into structural drawings, what to look for, how to read them, the important components of them, and we're going to go step by step. And today we're going to start with foundations.
Correct.
Exciting.
So do you see my screen?
I can, but let me share it to our stream.
Okay, got it. What the heck is this, man? Oh,
Technology, man.
So you see my screen now?
I can't. There we go. That's the one we're looking for.
Okay. So now, until now, we discussed about the architectural plans, elevation, sections, and notes and details. Now we're going to the next section, which is structural, right? So just go back again. This is the house we're talking about. This is the rendering of the house. You see it, right?
Yep.
That's the house. That's the front, back, night. So I just wanted to refresh everybody's memory, which house we were talking about. So now, so this is how the structural drawing starts. Okay, first page you see is your structural notes. Okay, it's the same thing in the architectural drawing. If you remember our first page, I'm going to go to the first page. This is kind of cover sheet, you know. This is a cover sheet and code data. See, that's the first page. This is a cover sheet and it's architectural drawings. But now, now going back to page number 10, that's the first page of the structural drawing that will show you structural notes. And I'll talk about this one, what the structural note covers on this sheet. The second page is a foundation plan. So the foundation plan and the basement plan is almost the same. So basement plan, or if you have a slab and grade, it could be first floor plan because there is no basement, crawl space. That's all architectural term. And for that, the foundation part is a structure. So doesn't matter, it could be full basement or crawl space or slab and grade. But your foundation, you still need a foundation, right? So that's what the foundation plan would be. If that makes sense.
Yep.
So then that's the foundation plan. That's the lowest floor. It's a framing plan. This is a first floor framing plan. We'll talk about that next episode. So this is a second floor framing plan. All the framing. This is the roof. And this house has a flat roof, so that would be a little bit different. Usually we have a slope roof, but it's a flat roof, but it's still trusses. And this one is called wall bracing plan. This is very important these days, anywhere, especially if you are in Fairfax County. If you don't have it, you don't get a permit. So there's we'll discuss what is this wall bracing plan is, how you design it, what is the concept behind. We'll talk about that when we get there. So you have to have this wall bracing plan. So framing plan and wall bracing plan. Okay, two things you have to keep in mind. First floor wall bracing plan and second floor wall bracing plan. I have calculations also attached. So then you go all these, some of the typical details that the details that applies to your project, but these are all the structurals, right? All of this.
So a structural drawing, like just to confirm what the difference between what we've already looked at in our previous portion of our series so far is, this is really a minute breakdown, right, of exactly how you're going to build a specific component versus this is the gist of how we're putting all of this together on the basement. This is how we're putting the second floor, right? Am I understanding that correctly?
Correct, structurally, because there would be more detail architecturally. So there is a difference, right? You have a building structure, there are components, there are structural component, there are architectural component, there are MEP component. I don't have an MEP plan, electrical, plumbing, HVAC. That part is not here. But every component or trade has its own purpose, right? So structural drawings means the structural component of the drawing that's holding the structure, right? So all this detail will show how your foundation should look like, what's the thickness of the footing, what the concrete walls look like, what's the rebars. Now going to the framing plan, floor framing, on the floors, you'll see what the beams and steel beam or wood beam, LVLs, microlam, how many jack studs, king studs, all that information, our structural information would be on the structural drawings.
Got it.
That makes sense?
Mm-hmm.
Okay. Now I'm gonna come back to my first page, which is the structural drawings. This is a pretty standard. So any structural specification will be here. So I'll tell you what you're saying. What is the structural specifications? So it started with the concrete. So when you say concrete, they have different type of concrete. It's like normal. There, like in general, you have a normal weight concrete. That's what we use. There's a lightweight concrete. You can use a lightweight concrete too, because there's certain applications where you have a lightweight concrete. But this concrete we use for usually residential construction is a normal weight concrete, right? Now, so when you say concrete, it has a different strength, compressive strength. That's what we say. So when you say concrete, usually you say, okay, what is the compressive strength of the concrete? You say, okay, 3,500 psi concrete, 3,000 psi concrete, 5,000 psi concrete. That's the strength. That has to be specified, because if you just say concrete, they need to know what type of concrete you are putting, right? So that's the specification will be here. So when you say 2,500 psi, the compressive strength of a concrete sample, which you have to do, is 2,500 pounds per square inch. That's how the strength is. So in the residential construction, I have to specify somewhere. So in residential construction, usually I specify 3,500 psi. I've seen some engineers, they specify 3,000 psi. But higher the psi is, definitely is more stronger, right? So if you do commercial project, concrete building, elevated, parking garage, it's like 5, 6, 7,000 psi. It's not 3,500 psi.
Yeah, strong concrete.
It's strong concrete and more expensive. So mostly when it's strong, you're putting more cement. That's it. You're putting more cement in rebar, because cement is definitely more expensive, right?
Yeah.
Because when you say concrete, you have to remember, I think we talked about this one just quickly. When you say concrete, it's a mixture of cement, sand, aggregate, which is gravel, and water. That's how you mix. And to get certain strength, let's say 2,500 psi concrete, there's certain ratio you have to mix together to get that 2,500 psi. That's why all these trucks you see running around, concrete truck, the batch plant is called batch plant, is they produce all this mass concrete, and these trucks, they bring it to the site. So, but again, sometimes you do on the site, so the sites are not that accurate, but that's why all these trucks are more accurate, because you do on the controlled environment in your shop, right? In their batch plant, we call it batch plant, and concrete. This truck will bring those concrete into the site. So there are some criteria you have to do, because if you take 2 hours, 3 hours for the concrete to come to the site, that's not good, because that concrete, once you mix it, it has initial setting time. Once you mix it, it's gonna start getting the strength. So within certain time frame, you have to pour the concrete.
Yeah.
Right?
Yeah. Otherwise, it's going to turn into a block.
Correct.
It's going to dry out.
So if you see this one, so I have a general. So we are in Virginia. So be in 2015 Virginia Residential Code. It's all that information, all that assumptions are here. So now site work, just like how you prepare the site. All that information is here. See? So number one, I'm going to read because we talk about this frost depth. That depends where you are, right? In our area in Fairfax County, usually frost depth is about 24 inch. But if you go up in the Maryland, we do a 30 inch, your New York 36 inch. So colder region you get, the deeper you have to go, right? But that information has to be somewhere, and right here, bottom of all exterior wall footings shall be a minimum of 2 feet below exterior grade. Okay, and this would all tell you how to prepare the ground for the footing. Then you have a concrete here. So this will give you all the combination of the concrete. You know, there is specifications. I'm going to tell you, this is what I was talking about. I don't know where to go, but anyway. So the concrete. It will tell you, see, so Danielle, I was talking about how long it takes.
Mm-hmm.
Say concrete, if you look at this one, the concrete shall be placed within 90 minutes of that time. So it has to be poured.
I think it's that specific.
It has to be within 90 minutes. If let's say you bring your truck and the truck is stuck in the traffic in 3 hours, you have to take it back.
Wow.
Okay, because like you said, that's too late. In residential construction, people don't pay attention, but in my project, I do because I know that that's not good. So you're supposed to do it within 90 minutes.
Wow.
Yeah, and so here, number 8, the concrete compressive restraint at 28 days. So you have to remember the reason shall be 3,500 psi. So they have to use 3,500 psi concrete. Now you say 28 days because concrete, when you pour the concrete, it does not gain its strength immediately. It takes time.
Yeah,
so
it has to cure.
Correct. So it takes, technically it takes 28 days to get its full strength, 28 days. The problem is people don't wait. You pour the concrete, next day you start doing the framing, which is not supposed to be happen. But this is what happens. At least when you pour certain hours, it will get almost majority of the strength. In 7 days, I think it gets almost 70, I have to check, but 70 or 75% of the strength. So,
wow.
So the
That's
day
amazing.
longer it's a longer process. Sometimes it takes 1 year, 2 years to continue getting that strength. But like I said, that's very negligible. So the strength gaining process is quicker at the beginning, but as you go more days, past more days, its strength is process is slow. So that's why when you pour the concrete, you can't start using the concrete slab or footing immediately because you have to let it cure for a few days. And also you have to remember, okay, so you say, Raj, how do I wait 28 days? That's too long. Yeah, like I said, you don't have to really wait 28 days, but it depends. If you do commercial projects, you have to. For residential project, building a new house, I have not seen people done it. Then also you have to remember, let's say the starting point is a foundation. So once you do the foundation, you do concrete wall. After a concrete wall, around 2 or 3 days, people start actually doing the framing. The reason is that 3,500 psi concrete strength means assuming you apply the full load on the structure. Means the house is ready, people are already in, your furniture, your kitchen, everything is all fully loaded, right? But that's not happening, right? Because you are only framing. That load is not there. So even though your concrete has not gained that 100% capacity, you can start working, continue the work because you are not applying that load. You know what I'm saying? Does that make sense?
Yeah. Because it doesn't have the weight on it yet. So it's before what they're anticipating it's going to hold.
Yeah, so that's what you need to be fully cured to hold the whole entire structure, but you are just starting foundations. As long as they are good for a few days, you can continue the work. So one thing I would say, especially concrete wall, when you pour the concrete wall, you have to backfill. When you backfill, especially that applies to us in our area, we have a fully buried basement. means you have a full 8-9 foot concrete wall. But if you are in Texas and Florida, you don't have a basement, right? So you don't have to worry about that. But in our area, so when you have a concrete wall, you have to backfill. Once you backfill, you have to make sure you cannot compact the backfill, because if you backfill means you have to bring the machine, start compacting, it's gonna crack the wall. So always keep in mind that do not backfill but loose. And I see this mistake. Concrete contractors and the general contractor make mistake. They keep making these mistakes. And I've seen so many projects, even this year, 2 or 3 projects, where they quickly rush. They want to finish the house quickly. They backfill and they bring the machine and start compacting the ground. Your concrete wall start cracking everywhere.
Yep. Oh,
I've seen it. I have a photo here. I hate to say it. It's completely demolished, and we had to demolish one project. Not my project, but I was an engineer only, so I don't have control on the side. But as a general contractor or builder, we'll never let that happen in our project. But something happened in their project. I was the engineer of record, and I had to get involved, and we have to redo the whole thing. So think about how much expense, money is gone for no reason. Being stupid.
That's a lot of money. That could be like 40 grand or more, depending on big.
40, 50 grand. Could be even more. Ooh. So, and also you have, those are the specifications here. And also going back to concrete, I think this is what we're going to talk about, the specification, not even foundation plan today, because it's a lot to do. But I was saying, even the concrete, one thing I want to point it out, the concrete you pour outside, let's say you're pouring concrete on the pavers, driveway, walkway, should be different than the ones you pour inside the house, okay? The reason is the concrete you pour on the driveway, walkway, or and other places outside, the concrete is exposed to outside temperature again. Because inside house, it's maintained, so you don't see it also below ground, it's below ground, which is below the first depth. But anything outside, it's above ground, it's above frost depth. It's cold. When it's cold, the concrete will see the coldness. So you cannot use a regular, normal concrete outside. So you have to use, I don't know if you heard it, it's called air-entrained concrete.
Air in what concrete?
Air-entrained. Entrained is called ENTRAINAD. Right here.
So
okay,
what does entrained mean? Yeah, no, I see. So what does that mean? What does air entrained mean?
That's a good question. So all it's all outside concrete. So all air entrained concrete. Air entrained concrete. So this is a little bit more specific. Like I said, you cannot use the same concrete that you use inside a house for outside, because it's a different temperature, cold and hot. Also, you have to remember, especially if you are pouring concrete in a driveway, in the wintertime, your car or vehicle will bring all kind of salt and chemicals, right?
Yeah.
And that concrete can crack.
Mm-hmm.
So what happens, there's a different way of doing it. The air-entrained concrete means that you are injecting the air inside the concrete on purpose. And you ask, Raj, why, right? So because you have to remember, the concrete is a mixture of cement, sand, aggregate, and water, okay? So they're not supposed to be void, right? That's the idea. You have a big aggregate, you put sand, the sand will fill the voids, then cement will fill the smaller voids, and there would be still some voids, and water will come in and fill the voids, right? That's how it is, concrete is. And cement is chemical, so as soon as you pour water, there's a chemical composition going on, called hydration. So, and that's how you gain the strength. During that process, the water start evaporating, because when concrete dry, the water should not be there, right? But you mix the water there. So when the water lifts, becomes, it evaporates, it starts leaving a gap inside. So you're not supposed to leave a gap. So now I'm saying I'm putting that gap on purpose. And you ask why? Because this is what happens, especially in winter time. What I said, if you guys remember, the water is in general any type of material in the wintertime, in the summertime. Summertime, it will expand. If you have a more temperature, it's gonna expand, right? If it is cold, it's supposed to shrink. If it is cold, it's supposed to shrink. It will shrink. But if it is hot, means it will expand. But water is different. Water is, when the water freezes, it becomes ice, the volume of water increases by 10%.
Yep.
So it's a reverse. So what happens now is, right, okay, I have a air entrant concrete, I have a concrete outside, and it's raining, water goes inside the concrete, now it's frozen. What happens now? Frozen means that now the concrete, the water becomes ice, and ice volume is 10% more, and they start putting pressure around it. And that's how you start seeing crack all over. So, but now when you say air entering concrete, you put more air voids there. So that means when the water freezes, becomes ice, when it expands its volume, there's a room for expansion. Because you put air inside on purpose.
So how do you get the air into the concrete? Is I guess my even bigger question.
No, that's the good point. Yeah, you have a chemical. So we mix certain chemicals. So when you mix with the concrete, it creates more bubble and creates more air inside. Yeah, there's chemicals.
So kind of like an effervescence almost, like something that makes little pockets, like little tiny bubbles of air. You're not talking about one big pocket of air. It's like lots of little pockets. So the structural integrity is still there.
Correct. Yeah, exactly. There's so much you have to do. You see, also there's a requirements of how much of air you can put, and there's you have to say, you talk to a concrete batch plan. I want 5%, 6%. If you look at number 13, all concrete exposed to weather shall have a minimum of air entrant of 6% plus and minus 1.5.
Yeah.
So you want to put air, but don't put too much, right? And if you put too little, it's not working. So it has to be 6 plus and minus 1.5. That means 4.5% to 7.5% per ACI. The ACI is the code for concrete. It's the American Concrete Institute, and this is the clause for concrete guidelines. So
I didn't realize there was an entire institute dedicated to concrete. So I learned that today.
Oh, yeah. ACI.
I didn't know. Who knew? I guess not me. Okay. So
this is again 318. So I think ACI 318. You have like so many ACI. I mean, it's not just regular concrete. You have air entrant concrete has a specific, and sometimes you use a concrete for different application. High security places where you might be even blast resisting structure, things like that. So that's why they have like whole different sections of the code requirements for concrete with the different applications.
So exterior concrete, like concrete for things like patios, sidewalks, walkways, retaining walls. Would all of that be examples of things that need air entrained concrete?
Yeah, and also the patio, exactly. Yeah, you have to have that. That's exposed outside.
Very interesting, because like I'm getting my patio redone, and it's going to be stamped concrete. So is that going to be air entrained concrete?
No, it's stamped concrete. If you are pouring concrete there, yes. But if you're getting concrete blocks from somewhere, not. But yes, if you are pouring concrete there and making a stand like with the pattern. Yes.
Yeah.
Make sure that it's not the same concrete. And the guys who are doing this should know it. Yeah.
Oh, I'm sure they would, but I just wouldn't know to ask that question.
Yeah.
I didn't even know that word until today. So this is really good information. Okay.
I'll just play dumb. Hey, are you using the same concrete you use inside the house, or is it different? Because if you use the same, in a few months, a couple of years, you will see that concrete on the top part is start coming off.
Yeah, it like flakes off like
Flakes
chips
off,
in
yeah.
like little sheets.
Yeah,
Yep.
yeah.
That makes complete sense. Okay. So, and that's then not the same concrete you would use to make like a concrete countertop. Like you'd use a totally different concrete that you don't want those little pockets in.
No, yeah, those are different concrete, exactly. Those are maybe more
Okay.
fine, maybe aggregates are less. But like I said, yeah, depending on the different type of applications, your requirements are different.
Awesome. Okay. Very
So,
cool.
yeah.
This applies to me already, Raj.
Yeah, so I mean, even in concrete, like I said, we can talk about all that. There's so much to talk about, not just how the concrete gets to strength. What is the process of getting the strength? What can you do to control it? That's why. That's why if you see, before I forget, is in commercial project, if you are poor in concrete, in hot weather, you'll see they're actually spraying water.
Yeah,
because
they're spraying
you
with
pour
water.
Exactly, because you pour the concrete now, it's so hot outside, it's dry so quickly. And like I said,
Yeah.
if there is no concrete, if there is no water, there is no chemical composition between the cement and water, and the concrete will not get the same strength. Will just immature. So you have to keep spraying water. Sometimes they even cover with a cloth, so that you try to contain the moisture in the structure until the concrete gets full strength.
Got it. Okay. That you know what? Now that makes sense because they said they were probably going to have to cover it in like plastic because they're pouring this in 2 weeks, which is like almost July, right?
Okay.
And it's hot here now. It's been almost 90 degrees for like almost a month now. And that makes sense. So they're going to cover it and keep it moist, specifically to help it maintain its strength and structure or improve its strength and structure as it cures.
Correct. And also the application, load application for the patio is different because patio is sitting on the ground. It's like slab on grade. So there's a continuous. Make sure that you prep the ground properly so that it doesn't settle and there's no crack. So, but it's still sitting on the ground. But you're talking about the concrete, which is not sitting on the ground, and the garage, like commercial building where you have a slab. It's called elevated slab, not on the ground. Those has to be properly cured before you apply the full load. And so for that, they do a lot of testing. They have to do concrete testing. And that's another whole day topic. But then you have to do testing for the 7 days. You have to do 14 days. You have to do 28 days. They make a different cylinder, a concrete cylinder.
Yeah.
And they test.
Okay.
And if you then sometime, otherwise, how do you know it's the concrete got strength? It's supposed to, because so you do test, and sometimes you even go to the structure itself. Let's say slab, you can actually core drill, bring a sample, and do the testing.
Oh, huh.
Yeah, core drill.
Kind of like how they drill into trees to test, for age and all sorts of stuff. But similar, you drill into the concrete to test for the strength of it.
Huh. Yeah, so you drill the concrete, bring the sample, come to the lab, and do the testing. Yes.
Interesting. Okay, cool.
So this section is for wood. For the wood, you have a different code. It's called, you have to remember, we're talking about IRC, International Residential Code. That will only give you the general guideline. But for each item, then we have a different code. For concrete, we already said it's ACI. For wood, it's called NDS, the National Design Specification, NDR for wood construction. So you follow that, These are all the requirements, what type of wood you can use, what's the specific species, water content. So, for example, if you are using the wood outside, has to be pressure treated or should be treated. So all the requirements are here. For the wood section, I want to finish it in 5 minutes, so I'm gonna. So next section is steel. So you have, even the residential construction sometimes you have a steel. So if you have a steel, then this is the specification. The steel is different code, AISE. That's the specifications for American Institute of Structural. I don't know what it's called. I forgot, but yeah, SE is the code for steel.
You know what? Now that you're describing this, it totally makes sense to me. But I never really thought, as like someone who doesn't, I'm not in the business of specifically picking my materials of what I use to build things or renovate properties. Like I don't get that deep into it. I work with other people who do. But now that it's being explained that like a bolt needs to have these types of qualities to be usable for this kind of project, I never really thought about it in terms of strength. I always thought, oh, that's the size that you need. Or like, I don't know how I thought about it, but I'm sure that maybe there's other people out there that hopefully will comment and not let me be the only one out here who had no idea, or I just didn't put it together that the size and the shape and the material made of these things really is very specific to the job that it's doing. And it's all been calculated and measured to make sure that it then is part of like a safety and structural component. Like it's a lot more nuanced than just, oh, it's a bolt. This is the bolt we use. You know?
No, you're right. I mean, like I said, you don't have to get, if you're just a builder or contractor, you don't have to get into this nitty gritty, right? But me as a structural engineer, that's what I've been doing since 2000, almost like 20 years now. So these are the things I need to know. I need to know what I'm specifying. If I'm designing a structure, I have to know what I'm specifying, right? And these are all the details. If you have a steel beam, for example, W-shape is an I-beam. This is a specification. A plate is different. Tubes are different. Bolts are different. Like you said, bolts, it's a different specification.
Yeah.
But manufacturer, wherever you buy from, I mean, they have to make sure they comply with that. So we know that they will do it. And they are ASTM, American Society of Testing Materials. This is the one that's control the quality of all the construction material pretty much. And all these shops where they prepare this material or produce, they have to comply with their requirements. They'll make sure that the material they prepare or produce are in compliance with the required capacity, right? Strength. So that's for the steel, and this is for the trusses, open web roof trusses. So mostly residential construction will have roof trusses, prefab. That all is specifications. For that also you have a different topic. Even roof trusses, you have a different section that you have to follow through. So that's all information is here. And like I say, I don't think anybody would read it, but I have to do it to cover me just in case. So that's part of the general CYA, cover your back notes so that just in case nobody read it, but should be there. Yeah.
Yep. No, and it's good. CYA. I mean, it's a clear outline of what you're going to be doing and how you're going to be building it.
Yeah. So same thing here. The wood species. I'm specifying what is the capacity. These are the common wood species we do. Hemper, SPF, southern pine fir, microlam. I'm not using it. Yeah, southern pine. So SYP. So all the yellow plant. Usually all the studs, the headers are hemper or spruce pine fir, but southern pine usually rafters. I would say headers and plates are southern pine. Pressure-treated woods are usually southern pine. They're different. So we put there. This is abbreviations. This is the design load information. So here you'll see I have a roof, 17 dead load, 30 live load, 30 snow load. So all the loading information has to be also documented because these load requirements could be different depending on the application, because this load would be different definitely if you are designing commercial building, office building versus your house, right? So first, if you see roof, dead load, live load is snow. So of course, right now, ground snow load in our area is 30 pounds per square feet. But if you go different place, this number will change. If you are in Texas, Florida, this doesn't happen. So it's not there. So these are all the design load criteria I have to do. This is a wind load because you have to design for wind. All the information is here. The deflection criteria. So this is the concrete. So now with the concrete, so you may think like, okay, Raj, you have a footing, you have a rebar. So where do I place that rebar, footing rebar, right? Because do I put that footing rebar all the way on the ground, or just, and then pour the concrete footing on the top, or it has to be somewhere in the mid height or mid thickness of the footing, right? It has to be towards the bottom. All the information somebody has to show there, right? Otherwise, concrete guys, they just put the rebar there. But if you just throw a rebar there, if you're not, installing correctly, that doesn't mean nothing,
Yeah, it doesn't have the same
capacity,
structural integrity if you change the plan and don't do it as per spec.
Intended, yeah. So these are all they cover. So if you are laying the concrete directly or pouring concrete directly on the ground, there should be at least 3 inch gap. That means that, okay, going back to footing, let's say I have a 12-inch thick concrete footing, 12-inch thick. Now I have to put rebar. That means the rebar has to be about 3 inches up from the ground. See, that's it. I'm saying 3 inches. We have to put minimum 3 inches or maybe 3.5 inches. So how they do it, they put, piece of, sometimes I see rebars or sometimes they have a chair. I mean, for residential construction, I have not seen it. Usually contractors, they just use those aggregates, the bigger size, to hold it up in place. But in commercial projects, it has to be perfectly done. And you can buy metal chairs with exactly 3 inch or 1 inch, 2 inch chair where the rebar can sit on, so that you can maintain that gap or clearance correctly, or cover. It's called a cover, concrete cover correctly. Because if you don't do it correctly, you don't get the strength. Yeah, like you said, if you don't pour those walls and installation of the rebars are not correctly placed, then your strength is not the same.
Completely changes it. That's very true.
Exactly.
And it's important to know. It's important to know. Yeah,
so see, that's what I'm saying. You just put a rebar on the wall, doesn't mean it's going to do the work, because if you did not install it correctly, and I've seen it all the time, I understand it. A lot of contractors, builders, project managers, they are not structural engineers. But I say, if you don't know, ask. Ask your structural engineer,
especially before you pour concrete.
Yeah, rather than assuming it, I think you're good. Just ask the engineer. It just takes up one phone call, especially in your structural engineer consultant is paid to help you, right?
Yep.
So anybody asks me, sometimes I have some client, they try to understand the whole drawing, but I say, dude, okay, you pay me to design this house as a structural engineer, but I don't have time to sit down and teach you how to read the plans, right? Because I don't. Some people ask so much detail, but I say, okay, that's a different scope, because if you want me to teach you how to read the plan, then I have to have another one-on-one and another proposal or contract I have to send. But like I say, if there's 1 or 2 smaller items you need to know, it's better to ask.
Oh, absolutely. Awesome.
Well, to be honest with you, I think that should be it.
Yeah, this has been really helpful. As usual, I've learned a lot. And if anyone who's watching today has any other questions about concrete or cement, which are not necessarily the same things, depending on the day and the project, or if you have any other questions about structural drawings, specifically with the foundations and what we talked about today, leave your comments below and Raj and I will get back to you. So we're not going to be here next week, but in 2 weeks, we are going to be talking about flooring framing. So we've talked about framing in other episodes before, but now we're going to look at the structural drawings with the framing and possibly some examples too. So we'll be tackling that in 2 weeks.
Sounds good. Thanks. Bye.
Awesome. Thanks, Raj. Bye.
Bye-bye.